Hey guys, I wanted to give you guys a little bit more practice and a little bit more guidance on the arithmetic and geometric explicit definitions. So the first thing that we always want to do is determine whether the sequence is arithmetic or geometric. So remember, if a sequence is arithmetic, then that means that we are adding a constant every single time. Okay, now if the sequence is geometric, it means that we are multiplying by a constant every single time. And constant means the same number every single time. So if it says add a constant, it doesn't mean add 1 this time, and then 2 this time, and then 3 this time. It means you're adding 1, then you're adding 1, then you're adding 1, then you're adding 1. And multiplication is the same way. So when it says you're multiplying by a constant, it means that you're multiplying by the same number every single time. And I'm sorry that my handwriting looks so childish because I'm doing this on my trackpad because my pen is not working. But you guys will get the drift. Okay, so if we look at this first sequence up here, okay, our sequence is 5, 7, 9, 11, 13. And if you think about it, there's nothing that I can multiply to 5 to get 7. There's nothing that I can multiply 7 by to get 9. So this is not a geometric sequence. But we have to figure out what the arithmetic sequence is. So if we start with 1 and we subtract the 1 before it, that will help us figure out what the common difference is. So remember, the common difference is just that constant that we're adding every single time. So if we take 13 minus 11, that tells us that our common difference is 2. So with that arithmetic sequence, and we're going to write this in function notation. So anytime it says function notation, what it means is that you're just using like f of n or v of n or f of x or v of x. Okay? So the common difference is 2. That means that that's basically our slope. So when you're doing an arithmetic sequence, you're doing y equals mx plus b. M is your common difference. So in this case, we're going to do 2x plus, and now this is term 1. We need to figure out what term 0 is. So in order to do that, if we go this direction, we're adding 2 every time. So 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13. But if we want to go in the opposite direction, then we need to subtract 2 every time. So if we take 5 minus 2, then that tells us that our 0 term would be 3. So that is what we are going to add on here, because this actually represents what our y-intercept is. And I just realized I screwed that up. This would go over here. And this should be that this is an arithmetic sequence. It's late at night. I'm sorry, you guys. So this would be the explicit definition for this arithmetic sequence. All right, so now let's look at the second term, or the second sequence. So we have 8, 5, 2, -1, -4. So again, there's nothing that I can multiply 8 times to get 5, nothing I can multiply 5 times to get 2. So we know that this is not a geometric sequence. We know that this is an arithmetic sequence. So I'm going to let you, I'm going to pause this for a second, and I'm going to have you guys fill in what you think the common difference is. See if you can figure out the common difference. Okay, so the common difference here should have been -3. And I'm just going to put an A in here for arithmetic because I can't write that long. It's going to take me forever to write that. So what I'm going to do now is go ahead and pause, and I'm going to see if you can come up with the explicit definition for this sequence right here. So for this sequence, I'm going to zoom out again. For this sequence, the other thing that we have to figure out, this is term 1. We need to figure out what term 0 is. So in this direction, we're subtracting 3 every time, which means that to get the term before this one, we need to add 3. So this over here would be 11. And so our explicit definition would be f of n, or f of x, or whatever letter you choose here, whatever variable, is equal to, now remember, the common difference is like your slope. So this would be negative 3x, and then this number here, this 0 term goes on the end, so plus 11. Whew, that got kind of crazy there at the end.